In this video, you will rethink obstacle detection in terms of repeated decisions, like the ones you used to complete the strawberry plant sorter. The two requirements of our obstacle detection task, moving 4 rotations and moving only when the way is clear, are fundamentally linked. Both have to occur at the same time. Checking rotations can't block out checking for obstacles, and checking for obstacles can't block out rotations. But that blocking is exactly what is happening. Using a forward command for 4 rotations blocked out the distance sensor. And using wait untils blocked out the motor encoder. We can't solve this problem without changing the way we look at the task. So far, we've been looking at this as a single, large movement with 2 things happening at once. Instead, let's try taking turns, quickly. We'll break the big movement down into a series of tiny movements, and give both the distance sensor and the motor encoder a chance to make their decisions in each tiny movement. We'll base this program on the pattern we used in the last chapter to make repeated decisions, an if-else conditional block inside of a loop. In each tiny movement, the robot will look in front of it to see whether the way is clear, and based on that decision, flip the motors on or off. The robot will repeat that decision as long as its motor encoder value has not passed 4 rotations yet. Let's put that into code. Begin by opening the Obstacle Detection Starter program linked to the right of this video. Start with the if-else conditional block. Set the condition to check if the value of the distance sensor is less than 100 millimeters. Add a Stop Multiple Motors command block to the if branch. And select left and right motors, connected to ports 1 and 6. In the else branch, add a Set Multiple Motors command block. Leave the speed at 50. Select your left and right motors, connected to ports 1 and 6. Now, add a repeat until loop to the program and move the entire if-else conditional block inside it. Set the loop to repeat until the motor encoder value of the left motor is greater than 1,440, 4 rotations. Place an object in front of the robot while it's running, and remove it. Repeated decisions allow your robot to check each sensor in turn, without either one of them blocking the other. The program continuously checks, responds, and repeats quickly, as long as no command blocks any other.